Now I would like to invite our good friend and partner, former SMALUC project coordinator. This project gave a new start to the students' education in our university. We welcome Antonio COMI. He is full professor in transportation at the University of Rome Tor Vergata and lecturer in transport system theory and freight transportation logistics. Antonio's scientific work has had an impact on the scientific community, as evidenced by an H index of 27 and more than 2,300 citations. In the last two editions of World's Top 2% Science, published by Stanford University, Antonio COMI was included in the ranking of the 2% most cited scientists in the world. So, Antonio COMI, please, the floor is yours with the topic electric mobility, opportunity and challenge in implementing vehicle-to-grid service.
Thank you very much, guys, and particular to Olga for this good introduction. It's a pleasure to attend this conference and to have this brief speech about new challenges that we have in improving our city. Now, let me share my screen, and I will try to use this. Let me know if my screen is possible. You can see my screen. Yes, you can see?
Yes, okay. We see your screen.
Okay, thank you. Then I would like to introduce you about these new challenges, that is the opportunity to adapt, to integrate the electric vehicle with the system of our city. In particular, we know that currently our people in the city is increasing, and it's expected by that the next year the world population will reach about the 70%. In this context, we have to go to fight with a lot of issues related to the congestion, with the increasing of the travel time and the time lost only for moving. But then we have some problems with the environmental, with a lot of pollution and the creation of our city that is reduce their livability. And as well as before, the Professor Percy spoke and introduced us with the social sustainability related to the problem of road accident. Of course, in our, but the international community, the international context tried to solve these problems. And in particular, in 2015, they defined the Sustainable Development Goals within the Agenda 2030. In particular, we have that one of the 70 goals was devoted to the city, and in particular the target 9, one of the target is specific to the attention of reduce their environmental impact in order to reduce and to improve the quality of the life within the city, also in terms of health and well-being. The European Commission organized in the last years promoted the Fit for 55 in 2030. Within this regulation, with the new legislation, the member states would like to reduce the impacts due to the pollutant emission, and taking into account that the transportation consists of the 15% of emission. In particular, they organized, they agreed to have a plan to reduce the impacts from the electric, from the transport, from the road transport, and then looking at in 1935 to have no vehicle with internal internal combustion. And then it's important, then we have to reduce, and this is the main goals. According to this, we have that in Europe and around the world, we are increasing the number of electric mobility. We are to change and to revise our vehicle fleet, moving towards the electric one. In particular, the electric one could have a lot of benefits for the cities, however, also in particular because they can reduce the pollutant emission, they can optimize the dependence from the fossil fuel. In this context, we have that the different countries promoted the adoption and the renewal of the fleets, and in particular, we have the large market of China that pushed a lot of money in this transition. In Europe, the situation is not so good. In particular, we have that different countries move differently in terms of vehicles, in terms of incentives to this transition. In particular, we can see that in these slides that Germany, France, and Italy, for example, have different share of penetration of these electric vehicles. And many of the situation in different countries depends on the stop of subsidy policies. In particular, we can see that when the incentive stopped, also the sales of electric vehicles stops too. Only in Norway we have a better situation. In this, and then we have going inside the different vehicles, and in particular on this vehicle, we have a lot of different type of vehicles that can be used, can be adapted to use for transition, for accomplish the user's needs. In particular, but during and in particular, we have that the vehicles are more related to collect. Usually, we can see the vehicle as a vehicle that collect obtain energies from the grid. But all these can cause some problems to the grid because we have to produce this energies, and this energy is can use. We have to revise our production. But according to the different kind of vehicles, as we can see, we have some vehicles that can be connected with the grid, when communicate with the grid, in order to have a system that receive and pass energies. In this context, we have new technologies that are called the vehicle to grid. The vehicle is not only considered a user of the energies, but is also considered a producers. In particular, we have a different type of this connection that going from the vehicle to home, usually, or vehicle to grid. That is the focus of this speech. In particular, we have that the electrical vehicle can be connected to the power grid to obtain energize, as well as feed energize back to the grid. Since each vehicle is quite limited, the aggregator turn to the group for changing and discarding, as well as for grid regulation. What means that usually our vehicle collect, obtain energize from the nectar during the peak, the off-peak hours, during the night when they are at home. But during the peak, for energize, not for traffic, we have to that they store this energize. A lot of this energy is stored in our vehicle, parked and remain parked for a long time. Then we have that we ask to the grid to have more energize. A problem, the innovation that is in, and then we can use this large number of vehicle parked that unused energize for supporting the electric vehicle, transferring the energize, or when it needs for frequency regulation. This is an innovation. Of course, in this context, we have a lot of benefits, because don't stress the system to produce a lot of energies only for going around going facing the request, the changing requests during the day. And then because we have some battery that are parked, stopped, and with the energized don't use it, but was produced during the off-peak hour. In this context, then we have that this energize can be optimized, and we can imagine that our vehicle is a mobile source of energize, can be used when they are parked as a stabilizer. Going inside the opportunity, in this vision, we have that the electric vehicle are not considered only as consumers of energy, because consumers of energy could be almost limiting. It does consider that the possibility of using the vehicle battery as a device for the accumulation and release of electricity on the grid on the basis of a need, according to this request from the grid. Then and also we have to consider in our parking, close to the office, close to the school, we have a lot of vehicles that could be remain stopped for a long time. And during this time, then they are stopped because we are at the office. We ask to the electric grid more production of energies. Then we have from one end, we need more energies. From the other end, we can increase the cost for production, the cost not only for the money cost, but also for the city, for the sustainability. And on the other hand, we have a lot of energies parked in brackets in our lots, in our parking lot, that are then, and in this, then we can use these energies in order to optimize the system. Then we have to look at our vehicle as a member of a component of a whole system, where we have mobility, where we have the production of energy, and they work together, exchanges the benefit. Usually in the current, then the new challenges in order to integrate in the whole system of our city is that it is important to explore these unused energies and the benefit that we have for the use. We in the literature, if we go around the scientific literature, we have a lot of works that studies that have performed, developed with vehicle to grid, vehicle to home, or vehicle to vehicle. But however, mainly all are devoted and point out the needs of the technological aspects, going how is possible to do. Now the technology exists. Also, we have some vehicles, electric vehicles, that are equipped to have bidirectional connection, because of course it's important to remember and to note that not only the vehicle that produces nowadays are allowing to have the bidirectional exchange with the network. But now new vehicles are coming and we have this opportunity to have this exchange. But which could be the benefit for the city? Then it's important to go inside the new challenges. The future is not only remain but on the technical, because we are ready to support this innovation in terms of technological aspect, but the aspect related to the city planners, the needs of the people, how to implement it in real life is not so explored. Why to use vehicle to grid? We have a lot of opportunity. We can go from the network support in order to stabilize the network during on the peak hour, or the economy. We have to consider that usually the energy peak doesn't follow the mobility peak, the transport peak. because when we are at office, our vehicle are parked, and so on. When the economic benefit, in order we can optimize the production of the energizer, and we can have a stabilization of the production. We can use this mobile. This also we can collect from energizer coming from the renewable resource, wind, solar, and so on, sun. Then during the day, and we store in our vehicle batteries. We have a lot of innovation on this. Of course, then, according to brief framework, we can see that the vehicle to grid could help to build a greener, more efficient and resilient energy system that is aligned with the goal of sustainability that were defined from with the introduction of the Agenda 2030. In the scientific world is different around the world. The attention to this topic was quite different, going from China and the United States, and also Europe and so on. We have also, as we can see in this picture, in this on the top, on the bottom, we can see that here we have the China and the strong connection with among the different say. Also, there is a strong connection among China and the United States are leading this research. As I said, but they are mainly concentrated on the technological aspects. This vehicle, we have a lot of challenges, key challenges that we can identify. For example, which is the best time for parking and charging? And charging when we have to develop some methodology, some optimization process that can discover when it's better to produce, to be connected with the electric grid, and where to start with the charging. We have to identify the best location where to equip the infrastructure in order to have, because it's obvious that the vehicle to grid cannot participate alone, but we need that we have an aggregation of the vehicle. And then for planners, becoming relevant to identify the best location where we collect these, where to incentives this use of vehicle to grid. Of course, we have to know how to investigate. For the new challenge is how we can forecast the energies that can become from the vehicle, from the electric vehicle. And then we have to go inside the vehicle usage in order to discover how the vehicle is used and which is the performance of our vehicle, which is the level of energies when the vehicle arrives at the park, and which is the level of energies that the user needs after parking. Because of course, in order to incentive the preference, the user participation, we have to create a system that the user participating in this service cannot penalize. What means this? It means that the vehicle, when I go to take again my vehicle, I am able to be sure that I can continue my travel, my routine without penalizing. And then it's important to go inside some methodology that to go inside in order to discover the user preference and how the users use the travelers use these vehicles. And also, of course, it depends on the socio-economic characteristic, depend on the characteristic of energies, as well as also the climatic condition, environmental condition become very useful, very relevant in order to know exactly how the degradation and of our battery. As we can see, we have a new world, a new frontiers for research where we can, but of course, we have to develop some methodology for this. We have some issue, some concern related to the privacy of the risk. We have a connection because someone knows, probably we have a barrier related to the fact that the travelers have to share the information about what they want to do after the travel of the parking, after participating to the vehicle to grid. the security of the information. We have to know another aspect very relevant is the battery degradation. As we know, according to the current research, we know that charging, discharging in the quick charging or not can degrade our battery, and we are not sure that, and when we are be sure that the users are compliant with that, and the innovation also should be go inside the battery in order to create some infrastructure, some tools, some equipment that allow to go to suffer over this. The opportunities for consumers can be different. They can optimize their users, buying energized low price during the night and selling energized during when they need and they will create an income. We can have they can have also for the benefit for the grid, because they can increase the stability without asking the firm, to the plant, to have extra work during the period, and we can optimize the capacity of our energy plants. In this, of course, we have some real problem in the implementation in order to create the scheme, the pattern that for its real implementation that is related to the end consumers, the vehicle and the electric vehicle owners, then the planners, the city planners that have to create infrastructure, parking infrastructure, charging stations, so on, as well as the power grid. We have a different actors that until now work one independent from each one, because we have the power grid owners usually doesn't face with the needs of the city planners, because it's another, in particular with the mobility planners, as well as the city plan, the planners have to take into account the benefit that to share the needs of electric vehicle owners, which is one of the main aspects, according to what we are saying, coming from demand forecasting. And then that is depend on the temporal use of electric vehicle, the spatial use, and the energy use. According to this, we started to have a brief methodology. I would like to show you a preliminary study that we developed in order to support, to justify, to assess which could be the benefit from this new service. In particular, we try to investigate the real use of the vehicle, then in order to identify the best location, and then to have the which is the energy that we can transfer to the net. In general, we have two main steps. The first stage is the car trips assessment, where we have to investigate how the vehicle is used, where is parked, for how long is parked, which is the activity performed after parking. Because in order to support, to incentivize the participation in vehicle to grid, we have to consider that we have not to ask users to revise their routine, but in order to increase the share of participation, probably it's better that we try to have a low level when we don't ask users to revise their routine. It means that after work, I go to the gym, I go to supermarket, I can continue to have all this travel because I have enough energized in my after the participation in order to continue to do what I would like to do. Then this is the possibility to have the technology allow to have the trace in the vehicle and to know exactly what is happening. Then we have the second stage of this methodology should be to identify which is the best location, where to have a lot of parked vehicle with a lot of energized, a lot of, for a long time, that meet the real needs, the temporal period of the network, of the electric grid, in order to mix and to allow that the energy to transfer could be the best one. And then we have to do a land use analysis in order to identify the potential location where to implement vehicle to serve to grid vehicles, as well as we have the schedule where we identify the level of acceptance by to participate. Then we have to investigate the level of the battery in order to know exactly which is the energy that we need. We have to, and then we have to collect this amount. This methodology was primarily applied in the city in a small city using some sampled vehicles, and then we use for the whole region always in there. This is the city of Padua. Padua is in the northern Italy, is a small city, and we consider is a medium-sized city, and it's and we consider the city with the municipality around. This is the zoning that we performed, and in this zone we have some different activity in terms of different, for example, the shopping and so on. This is the sampled vehicles, an example of travel destination sampled by for 5 days of vehicles. And this is the main points of interest where we have a lot of space, a lot of number of parked for a long time, and we identify all this. Among these red points, we have to choose the best one, to identify the best one, according to how long, how many vehicles, which is the spaces, which, and it is the time when the vehicle are parked is congruent with the time when the electric grid needs to have energized. For example, if we go, it's not interest for this analysis, the residential area, because we know that the vehicle are parked during the night when the electric grid doesn't need energy, extra energy. Then this is the yellow one. This is the 3 main identified points that we have some activity that during the day can provide energy. This is the trend. And we do an sensitive analysis where we identify 3 different levels of energy. And we can see that in this, for this sample, the energy that we can transfer, assuring the vehicle to continue their routine, the daily routine, could be enough. Then this methodology, I can go and ahead with this example for time reason. Then we have the science analysis, and it was performed for 5 main cities, including Padua, Rovigo, Verona, Vicenza, and Treviso. There are some main cities in the Veneto region where around the Padua. In order to have an idea, Padua is here before, and this is all the region inside, all the other municipality inside. We can see that the potential energized is strictly related to the travel pattern that are specific to each city. What we can see from this analysis, where we plotted 3 different shares of the autonomy, the level of charging, and of the battery charge after the participation to vehicle to grid services could be different. We have not parallel trend, but for example, looking at Verona and Padua, we have that they have the potentiality of to use the same level for 40%. But when we be able to assure that the 80%, the level of energized that we can transfer to the network could be completely different. Why? It depends on the of the use of the vehicle, because the people living in Verona usually have longer travel after parking, after the working, and so on. And then it's necessary to assure vehicle then the level of participation is lower than in Padua when the travel is short after the participation. After the conclusion, the case studies have shown that this strategical service would be very interesting. in order to have an idea, according to the energizer, we can say from this sample, we can see that each point could have a level of money that represents more than about 1 million of euros. That is with this level, and the vehicle to grid could represent a great opportunity for the future of mobility, and also to integrate electric vehicle within the whole system of the, not only to satisfy the mobility needs, but also to support the sustainability and the covering and the need from other economic. Of course, for the real implementation, we have some challenges related to the technological. For example, investigation, the stress, how the bidirectional charging and discharge, as well as the degradation of the battery. Regulation and policies, in order to create a good strategies, the framework of incentives to support users to collaborate, to evaluate the user acceptance and trust, as well as the collaboration between the different economic actors that go coming from automotive, energize, and battery provider, and as well as users, as well as city planners. In this context, thank you for this attention. I hope that this provides you a new vision of the opportunity that electrical vehicle can cover in order to support our sustainability. If someone wants to go inside some specific instead on the case study, can refer to this paper that already published and so on. Thank you, everyone. This is some picture of our campus. Thank you.
Dear Antonio, thank you for your presentation and your topic. Your speech is always connected with future, with very modern topics. Thank you for this. And please, questions. Okay, Ruslana, please switch on the microphone.
Thank you, Antonio. Thank you for your brilliant presentation. Thank you for your lecture. It's absolutely revolution, and I feel like I'm again in Vergata and listen you and try follow you with that neural network method. Thank you so much. But my question is it's really brilliant work. We will use at Zhytomyr Polytechnic. But my question is just a little bit tricky. What you, Antonio, will be to do if it will be some disaster, for example, war or flooding? What your system, is it include this case in your research?
Thank you, Rosa. It's a pleasure to see you again. It was a pleasure to have you as a visit in Vergata, and I hope that in the future we can continue our collaboration. So, thank you for this. Is currently this is not to go inside disaster. Probably we can consider in this preliminary analysis also the case of some disruption in order to see probably if we have some disruption of the grid, the electricity, the vehicle that are parked that are not used could be supported, could be a good occasion if they can transfer the network to the energize the network. Also during disruption of the electric grid, their potentiality could be very high, I suppose. And then it's of course it could be another use of this, but for covering also some disruption in general, disruption of the electric grid.
Thank you so much, Antonio. Just University Lund and that Svezia, they use a lot of electrical vehicle and even just roads that is electrical. But after war, they change mind because they just in case of war. So if we can that electrical system, all electrical, so we can be not winner in this war. Yes, Antonio. Yeah, thank you so much. It's very sweet. And
thank you.
Great.
Thank you, Ruslana. And we are fighting here who will ask you the next. One moment. Yes, but was Victor, okay, he will ask you, not others.
Hello, dear Antonio.
Hello.
I'm very glad to see you. Thank you very much for a very interesting report. Thank you very much for human support for us. It's very important to us. Indeed, V2G technologies are new technologies, services and new technologies that is widespread in the world. These technologies, V2G services, are very important for Ukraine for reconstruction and efficient use Ukraine's energy systems. I have a question. What countries is currently leaders in the implementation of maybe grid services, V2 grid services, of intelligent grid services, and what are the most successful for the practice? Thank you.
Okay. Thank you. Now we have to see that this is all, in general, we have some research acceleration. We don't have a systematic use. As I briefly said, we have a very limited fleet of vehicles that allow to be able to be directional. Now, at the moment, we are going to the implementation. We are ready, but is not for really and for large implementation. We have some cases, probably now the industry, the automotive and the electric engineer done, prepared always. Now the ball should be called to the planners to really implement and to have a large implementation on that. Because until now, we are studying, but we don't have real cases of implementation of that. We have some cases also in Europe. Also, the European Commission is financing some research project. But if I can see, we have some best practice until we don't have a real best practice. It is the new one. We are defining the road ahead, but we don't have a real case study. Thank you for this introduction. Sorry for not having point out straight very quickly this, but this is one of the limitations. The challenge is how we have to implementation. Now we have to go inside the implementation. And this case study that I presented, going inside towards this hand. It was a pleasure to see you again, Victor. It's a pleasure to meet you. Thank you.
Are you satisfied?
Yes.
Thank you. Thank you.